Bismillahirrahmanirrahim. Let us have a look at the first topic of this course, the nature of software. We will see some characteristics of software and the changing nature of software. Right, so at the end of this lecture, you should be able to first explain what is software, list and classify types of software applications, able to explain why software change, able to elaborate some characteristics of cloud computing, web applications, software product lines, and mobile application. All right. Now, what is software? So software is defined as a set of instructions or computer programs that when executed, it can help us to provide some functionality, some features, and expected to fulfill a certain level of performance. It also consists of data structures. It also comprises of documentations. Okay, so basically software comprises of all these three things. And what is basically software? Software is developed or engineered. It is not manufactured in the classical sense. It is not like hardware. Okay, because software doesn't wear out. Unlike hardware, because when you develop software, it will be used throughout as long as there is a proper modification, proper maintenance of the software. So if you look at this figure, you can see at the beginning of software development, it is common to see high failure rates of software. So the graph shows that as the time passes by, you will see that eventually the failure rate will decrease because you modify the software, you improve the software. At some point, one point of time when you do modification, perhaps due to some side effects, there's some spike here because of some failure. Okay, but eventually you will able to modify and enhance and improve the software, and it's getting better and better. So this is if you look at the down here, this is the idealized curve. Of course we wish the software to have constantly no error, but this is not possible. In reality, this is not possible because the nature of the software requires changes. It requires changes to make it relevant. To be relevant, it has to be changed. It has to be accommodative to the needs of the businesses. That's why you can see eventually there is a level of errors along the way, and this is common. Now let's have a look at some types of software application domains. Well, this is just some of the list of software application domains, categories of software applications. I'm sure that you have seen or used some of this, or maybe you are familiar with some or all of this. Okay, like system software, application software, engineering, scientific software, embedded software, product line software, web mobile applications, AI software. Right, and there could be more than what you see in this list. Okay, for example, nowadays everything's interconnected. If we have more IoT applications being developed nowadays. It goes beyond this thing actually. Right, now just to give you some examples of this software applications domain under the system software, this refers to a collection of programs written to service other programs. One good example is the compilers, compilers or operating systems, editors, file management utilities, APIs. These are all the system software that we use in order to provide some services to another applications. Okay, and then there is an application software. So this is typical. This is a common one that we use. It's a set of programs that solve a specific business needs and facilitates business operations and helps manage decision making for a company. So one example like human resource application for a company, or financial management system, yeah, for a company, or inventory system. So this is a normal application software. It's being used for a specific business purposes. And then there is an engineering or scientific software, yeah, like AutoCAD or MATLAB. So basically, these are software that support some engineering tasks or scientific tasks, yeah, and mostly be used in engineering or architecture. And there is embedded software. I believe that you are familiar with this one. Any software that resides within a product or within a system. Okay, it has some control features. For example, like software that is embedded in your microwave, or in your washing machines, or in your refrigerator. Yeah, software that's embedded in a car. Yeah, nowadays you have the smart dashboard, for example, in your car. So everything is automated. That is a kind of embedded software. And then there is this product line software. It's a program that come from the same family, and they have some similar characteristics, and to be used to customize different needs of users. One example here, I think the best example here is the Microsoft Office. Yeah, it has a series of, yeah, under Microsoft Office you can use Microsoft Word, PowerPoint, Excel, and yeah, they have some sort of a similar characteristics. And then there is this web or mobile applications, yeah, kind of programs that allows users to access the system using network, yeah. And then yes, AI software, like robotic system, expert systems, gaming systems. They use complex AI algorithms, and they sometimes involve complex computational features. Now, well, having seen a lot of applications in various domains, okay, now I think this is expected, right? Why software change? Yeah, but well, let's have a look at the legacy software first. What is legacy software? It's an older software systems that remain vital to an organization. So it is an application that is still being used, yeah, still being used by the company or organization, developed especially for a company, and it has a long lifetime, and typically use technologies that are now obsolete, right? However, they're still depending on the system. And if the company is still using the system that has been developed long time ago, this is what we call as a legacy software. Yeah, legacy software. For example, the company maybe has established over 50 years ago, and maybe they have some old systems. They may be written in languages like COBOL, like Fortran. I don't know if you have heard all these languages, in Ada. Okay, so those languages that nowadays, well, I don't know if we can find the programmers that can help us to maintain that kind of software. So we call it as legacy system. Okay, now why software change? Well, for the reason that it has to be adapted to meet the needs of the latest advanced technologies, latest computer environments. So if the software is not being changed or modified, it perhaps no longer relevant, perhaps no longer being supported. Okay, the software must be enhanced to implement new business requirements. For example, maybe the company have perhaps new policies or new standards or new ways of doing things. So the software has to be modified or enhanced to accommodate such changes. And the software also must be extended to make it interoperable with any other systems or databases. Okay, that's why you need to enhance, yeah, or extend the software where necessary. And perhaps to a certain point, it has to be redesigned or re-architected to make it viable within a network environment. Right, so these are all the situations that we cannot escape, yeah, and that makes software to keep on modify or customize or enhance or maintain, right? So that's the changing nature of applications. Like for example, if we look at web applications, yeah, those days it's very much only the HTML file, yeah, but nowadays the modern web apps are much more than hypertext files. Not only just the hypertext files with or photos, pictures, but it has to be accommodated with XML, for example, or Java, yeah, so that you can allow some sort of interactivity capability. And then perhaps it uses more new technologies like Web 3.0, okay, like and have perhaps implemented certain APIs, yeah, to enable interconnectivity between applications, right? And of course, there are some characteristics of web application nowadays. For example, it has to be data driven. Yeah, everything nowadays has to be data driven. It has context sensitive. For example, the quality, the aesthetic nature of the content remains an important determinant of the quality of a web app. It has to portray this continuous evolution. Okay. Also, there is these immediacy features. Yeah, the compelling needs to get software to market quickly. Because nowadays, if you don't market your software as fast as possible, other people will dominate that business. So, people needs to actually develop and market and the software in a very short time. Okay, it's very competitive industry out there, and it has to be secured. Okay, it has to be secured because when things are interconnected in the network, of course, there is no limit in terms of who can access it. Yeah, there's a possibility of a user who can hack your software, right? And other thing is the aesthetic values. Okay, this is an undeniable part of the appeal of the web application in terms of its looks and feel. Okay, and yeah, mobile apps, it sites on mobile platforms such as smartphones or tablets. It often provides access, yeah, to web-based resources and provide storage capabilities within a platform. And there is what we call as a mobile web applications and mobile apps. Okay, the difference is that for mobile web application, it allows the mobile device to access web-based content, while mobile app, it can give access to the hardware of the device and provide some local processing and storage capabilities. But as time passes, of course, these differences will become blurred. As the technologies advance, people will, of course, see no differences in this. And then there's cloud computing, as I explained just now. Yeah, cloud computing provides distributed data storage and processing resources to network computing devices, and it comprises this both front end and back end services. Okay, one example like our Google Drive. Okay, we use a lot of our facilities. Yeah, in Google Drive, it provides storage to us. Like for example, our application of iTalim, yeah, it resides in the cloud basically. So it has both services, back end and front end. All right. So cloud computing as a service, you can have an application or platform and infrastructure, each of these as a service. So for example, if let's say you want to have a storage, you can pay infrastructure. You can get that service, infrastructure as a service. And then about product line software, it's it's a set of software intensive system that share a common set of features and satisfy the needs of a particular market, like Microsoft Office product. It has a similar design, it has a similar look and feel. Okay, I think that's all. Sum up this topic. Okay. So there is an exercise. You can find this exercise in iTalim and please submit that. I think that is all for this topic. Thank you very much.